the servers we care about change the way that they operate. Turns out that legitimate clients will put in a host header that declares the name of the site that they were going to, that they thought they were going to. So if bar.com has a DNS rebind to, I don't know, google.com, Google will actually see bar.com in the host header. And then they might know that there was an issue and they could refuse to serve any content and so on. So in other words, the few sites that if you don't want to get hacked, make this change. This is not how security normally works. It's not how it actually works at all. But it will actually stop the worst of the issue, which is click fraud. The servers that actually receive clicks can be configured to go ahead, take a look, and see, okay, this host header was wrong. This did not come from content that I hosted. So you can do that. Where it massively fails are devices. Your printer does not know its host name. Therefore, it cannot reject, maybe my name is bar.com. It doesn't know. So the other thing that people have been talking about has been doing something to deal with external to internal routing. This has been going, I've heard of this from like 3 or 4 different sources. Why is it that a site on the internet can refer to your router inside? And you know what? There's an argument there, and I don't know what's going to happen with that. But it does kind of handle internal devices. When I say sorta, I mean you sometimes don't know what an internal device is. You don't. So here's what's weird about firewalls. There are 3 security domains. There's your LAN. You can tell something's on your LAN because it didn't come from your router. There's the internet. And there's your corp net, or your local net, or your behind the firewall net. You don't know where the firewall is. The firewall doesn't tell you, this packet came through the firewall. You basically assume if the packet reached you, your firewall was okay with it. Either it came from the internet or it didn't pass the firewall, one of the two. That's about all you know. So the problem is that saying, we're going to have an external to internal routing check, you don't know when you get a link somewhere that it's actually going out to a foreign network. It could just be going to the dorm 3 buildings away. You have no real way of knowing. And that sort of sucks. So ultimately, at the end of the day, we can half-ass fix some servers, we can half-ass fix some clients, but the browser as a generic router is probably going to live forever. I'm a little sad about that. So, have fun. So, one thing we can do, though, is let me see. Anyone got a time check for me so I know what time it is?
24 after.
24 after. Okay, we'll go a few minutes over, but not 2. Some of this stuff has uses other than breaking into networks. Who knew? When I started talking about network neutrality last year, I came up with a hack that actually worked, but it kind of involved flooding a link with so much traffic that it started dropping packets. It turns out you can't release code that involves taking down chunks of the internet. Even I can't. So I actually spent the last year thinking, well, what else can I do to possibly find out that someone... First of all, we need to stop talking about network neutrality. Network neutrality is the status quo. You don't beg for the status quo. What we're talking about is whether provider hostility is allowed. In other words, let me define provider hostility for you. You're sniffing my traffic, you're probably hostile. If you're altering my traffic, you're definitely hostile. If you're censoring my traffic, if you're selling my traffic to choice point, you're very, very hostile. Here's a very simple metric. If the U.S. Army would shoot you in the head for doing it, you're probably hostile. I'm just saying. So what do we need in order to detect provider hostility? First of all, there are 2 kinds of ways that a provider can be hostile to you. First, they can send your traffic at different speeds. So in other words, this kind of traffic is going to our internal voice over IP provider, fast. This kind of traffic is going to Vonage, 1 second delay. Things like that. The other kind is content injection, where you actually find out that they're actually changing things in the middle. Now, here's the issue. The internet is big, and there are lots and lots of hops, and at different speed and even different content can happen from all sorts of different locations. How do you find out that your last mile that your ISP is actually being hostile to you? Well, what you need is to know, given identical network paths for two websites, is the last mile provider hostile to content from one site versus content from another? Well, how do we know that they even should be looking for anything at all? Well, anyone who knows anyone who's working in the router space knows the carriers are basically demanding this. These are the features that are being built into the next generation of routers. The ability to change stuff, to slow it down, to inspect the crap, to read your email. Like seriously, these are the features that your ISPs are trying to buy. This is the decisions that they're making. There are repeated news articles about ISPs even going so far as to replace ads and companies setting themselves as ad replacers. This is interesting. Anyone here know about this Times Square effect? When you see Times Square in a movie, guys, that ain't Times Square. Even if it's not computer generated as a movie, all the ads have been replaced because there is no contractual obligation from the movie maker to show what was physically on site. Well, there's no contractual obligation between Comcast and Google to actually show the ads that Google put there. No contractual relation between Comcast and Yahoo to show the original ads. And Comcast is taking a look and they're realizing, well, I don't want to say Comcast specifically. All the ISPs are taking a look because they're saying, all the money's going to the ads, we're hosting the ads, it's going over our pipes, where's our cut? They finally figured out, man-in-the-middle attacks are awesome. They are the man in the middle. Let's go make some money. Exactly. And the deal is users don't care. Users tolerate ads. They don't mind that much. Let me tell you, you know how much you could make if you could say, I will make you the top link on Google on 10 million desktops? You will make money because Google won't sell that top link. You want that top link, you got to be good. And it's a lot easier to pay Comcast than be good. Comcast, AT&T. I don't want to pick on Comcast. They did some responsible things lately. So, one thing you can do, actually, it turns out, some consumer networks have transparent proxies. What this means is they take all traffic outbound in port 80 and coalesce them into a single proxy instance. And that uses the host header to route requests to the correct destination. Well, check this out. We have, with Flash, the ability to make a TCP connection wherever we like. Now, we've been using rebinding to move it, but eventually that's going to go away, and it's only going to go to one IP address. So the ioactive.com IP address is the only one I'll be able to make a direct connection to. But if you're behind one of these transparent proxies, guess what happens if you ask the ioactive IP address for Google's content? Well, the packet goes off to the last mile, says, oh wait, this is port 80, redirect to the transparent proxy. Transparent proxy says, well, apparently you wanted Google. Here's Google's content. So now, because of the transparent proxy, you can go ahead and retrieve content from other sites. Beyond being an awesome attack, though, here's where things get really fun. You can tell, I download from the proxy stuff from Google and it comes at one speed, and I download from MySpace and it comes from another speed. And you're always getting stuff from the transparent proxies. So you can actually specifically extract last mile specific data because all websites are hosted out of the same proxy. How awesome is that? Now, we can get even more fun. There's something called silent sensors. And silent sensors basically say,